I'm liking this. This is working out nice. Okay, we're going to talk about some right triangle math. I just pulled this up because I wanted to draw to kind of help maybe visualize again. This is in chapter 12, page 18. This is copied straight out of the book. So, not trying to trip anybody up, not doing anything too crazy. We're going to be talking about some right triangle stuff here. So, let's look at this and visualize this. I'm going to draw a triangle real quick. And this will be our generic triangle for, we'll use that for this whole setup here. So we're talking about side A, side B, side C, angle A, angle B, angle C. The 90 degrees is angle C. The hypotenuse will be side C. Just for the fun of it, let's go down here to this one here and call this angle A. That means this side will be side A. It's on the inside. This will be angle B, side B. Okay? With me so far? When you start talking about sides and angles with the triangles, the angle and the side that have the same corresponding letter will be opposite each other. So if I'm calling this side A or angle A, the side across, straight across from it is going to be side A. Same thing as side B or angle B here. The side across from that angle, we'll call that side B. Side C is going to be the 90. So real quick, just to refresh, the way I remember this, again, was my old high school physics teacher. Um, he had a story. I don't remember how it all went, but he talked of an American Indian named Sokotoa who used math. That's how I remember this. Everybody understand what those abbreviations mean if I shorten it up a lot? The sine of the angle is equal to the opposite side divided by the hypotenuse. Cosine of the angle is equal to the adjacent side divided by the hypotenuse. Tangent is equal to the opposite over adjacent. So just to kind of even help clear this up a little bit, it's like, wait a minute, we got this SOH and AH and OA, and I got ABC over here. So to kind of translate that from this to this here, if I was to say sine, the hypotenuse is always the longest side, right? So we will say opposite over hypotenuse. If we're looking at the sine of angle A is equal to the opposite side A divided by the hypotenuse side C. Yeah? The cosine of the angle, again, we'll say A. The adjacent side, since this is A, the hypotenuse is always the hypotenuse. The other side across from the hypotenuse is going to be your adjacent side. So this is going to equal side B over side C. And then the case of tangent of angle A is the opposite over adjacent. I hope this is seen well in the video. Maybe before I shut all this down, we'll move it. Try to get a better picture of it. This is what I remember. To try to kind of put it in terms of our uh, diagram here, that's how that's going to work. Anybody have any questions on that stuff yet?
Yeah.
Anybody else have any questions on anything else yet?
It's not a silly question, but my understanding is SIN is angle, means stands for angle,
The sine of the angle.
which is the angle number, like the value.
What I'm calling A would be the actual angular value.
That's the sine of the angle.
So you would key that into the angle into your calculator and then hit your sine button,
Yeah.
or hit your cosine, or hit your tangent. Yeah.
But what does that stand for exactly? Like the sine of the angle.
Ask your trigonometry teacher. That's a good question. What does that mean exactly? Kind of.
Trigonometry. I don't understand that why we need it.
Because okay, why do we need it? Because I say so.
Okay, fair enough.
You can use that.
Again, ask your trigonometry teacher. Get more into depth on that. I'm kind of more worried about the kind of math stuff. But when you, or Google that, the theory. That's one of the things I always hate about math books too. I felt like they never really explained anything. It was just do these problems.
You can use these equations to solve for any angle and any side on any right triangle. The purpose, like, there's no reason to like type in like sine 30 into your calculator, but sine of whatever equals the two sides of each other. You can use, it's like we're gonna have to find side B here, or let's say we have to find for that sine one, we have to find sine A. We have
let's focus on using angle A, 40 degrees here. We need to find side A, we need to find side B. What do I have? What do I know? I have angle A. And I have side C. I want to find side A. Right? I have A. I'm sorry, I want to find A. I have C. And I know what the sine of that angle is. So we're going to mix that up here a little bit. I'm going to change this. So the sine of, that's my angle sine A. Do cross multiply so I get A by itself times side C is going to equal side A. Yeah. So I take 40 times the sine. And I got a distance. What do you got?
41.05.
30,
41?
41?
No.
I did that without my glasses on. I could have done that wrong. Let me put my glasses on, try it again. 40, take the sine of that, multiply it by the side C, 55.09.
41.05.
Still get 41?
Yeah. Does it matter what mode you're in?
I'm getting 35.41.
And you're doing. Oh, I have to do sine 40.
Sine of 40 degrees times 55.09.
35.41.
40 degrees. 40 degrees. I was thinking 40. That's my good game.
Take the sine of 40.
41 too.
Times 35.41.
You have to be in degree mode or radian mode?
Yes, you gotta be in degree mode.
Okay.
That was gonna be my
There we
next
go.
question, was like,
Yeah.
you are in degrees, right? Not radian?
I was trying to work ahead and do some of these, and they were all coming out negative, and I was like, I need to wait. I don't know what's going on. Now I can do it.
So, yes, I'm getting, 35.41.
You're getting that too?
I did. Okay, we need to solve for side B now. Okay, we got two sides. We have all three angles. There's a couple different ways we can do this. How do you want to tackle it? Tell you what I'm thinking right here.
$42.20.
I'm thinking the old Pythagorean theorem there. I have C, I have A. I can find B that way. Or you could use the cosine of angle A.
Yeah, that's what I used. Cosine of angle A times C.
Mark, in case you haven't figured it out yet, there's more than one way to do it.
So 40, yeah. So it's
So what?
42.20.
How do you do? Oh, never mind. I'm thinking of. Okay, never mind.
What?
I was thinking of secant, cosecant, and tangent for a second.
You said 42.20?
Yes.
Hey,
That's
that's
what I
what
got.
What do you think?
It looks beautiful.
Not too hateful, not too crazy, not too bad. I want to jump down to number 11. I want to do number 11 next.
Okay. That'll be easy. I hope.
So what do we have? What do we know?
So angle A is 80 degrees. Let's take that out.
I'm gonna jot that one here. Angle B, you're correct, Mark. That's 10 degrees.
Well,
That's easy to figure out what this is here. That is going to be,
for visual purposes, it's better to change A and B because that's impossible to be that the 10 and that's the 8.
correct. Yeah, this is not to scale. So here's the funny thing, and I did this on purpose like this because we worked through 11 and everybody was like, wait a minute, I'm getting some really weird things that don't look right.
Yeah.
And it's like, well, if we were to look at this
Let's change that.
correctly, yeah, it's definitely going to be more like flipped.
It's a moldable demo triangle. You just gotta pretend that it's in
Yeah.
the shape that you want it to be.
Exactly.
Yeah.
What else we have? We have side B is 233.69.
Let's see.
So we already determined that is 80 degrees. So we want to find side A and side C.
Start with side.
We have a B, so we're going to be using one of these two first to find A or C. I'm just going to go ahead and jump on the tangent here to find side A first.
Okay.
Plus, you know, I'm looking at this, I like to work from left to right.
Mhm. So
It's kind of weird that way, I guess. So if I was going to write this out, I'm going to say the tangent of 80 degrees times 233.69 is going to equal side A.
Which is 1325.32.
Degrees, tangent. You said 1325.32?
Correct.
I agree with that. Does everybody else agree with that? Now, if you want, you could jump up and use the cosine. Or you could do the Pythagorean theorem again. If I have A, I have B. Let's find C.
So C in this situation equal B over cos A, right? Side C equal
Yeah.
B divided by cos A, or A divided by sin A.
I'm gonna just use the Pythagorean Yes. To find C, you know, what I might do, just make it a little bit easier on myself too, is I have A. So the sign, oh, is that right? Oh, I'm gonna get myself mixed up. I don't wanna do that. I just did the Pythagorean theorem. Something like that, right? Is that what you guys got? So yes, this is highly exaggerated. In all actuality, this triangle would look something maybe more like this. This was A, this was B, and C.
So side C would be 1345.76.
Yeah, depending on rounding. If you're within 100th, I'm not gonna get too mad about that.
You calculated already? No. Oh yeah, it would be something like that, yeah, actually. Side C.
Okay. Regardless of how this is drawn, looking at the numbers, we know C is the hypotenuse. The hypotenuse is always the longest side. So, after looking at this, does that hypotenuse we calculated, does that make sense? Is it the biggest number?
Mm-hmm.
That's good, right? If we would have calculated something that was smaller than 1,325, we know we also goofed something or came up with some kind of crazy number. Oh, that's right, we don't say goof anymore, that's the wrong word to say.
Yes, you can say goof all you want, it's okay.
We messed something up, that's what I mean.
I'm not stopping you. If we found side C that way, couldn't we find side C for the one above it the same way? We already have side A and side B, couldn't we just use the Pythagorean theorem to find side C and then use that to find the angles?
Yeah, you could have, do it however you want. Go whatever direction you want to go in. You only have one side and one angle, so you would have needed to calculate another side to use the Pythagorean theorem to calculate your third side.
I mean for 10, is that, I'm asking, is that
Oh,
a valid
I'm
way of
sorry.
solving 10?
Yeah,
Okay.
yeah. I'm sorry, I didn't realize, yeah, you're asking about
Sorry.
number
no.
10 here. Yeah, you got these two sides, Pythagorean theorem, boom, you got your third side.
That's good. Okay, sweet.
Any questions? How you guys feeling about right triangles?